Hello everyone and welcome back to Winter Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Andrei Semeniuk, an experienced data engineer, as he reveals the exciting combination of the LangChain and ChatGPT in DocInsight AI. Discover how these technologies work together to revolutionize data exploration, making research and analysis easier than ever. Don't miss out this change to learn about the amazing features of LangChain and DocsSearch and how they transform the way we interact with data. Now, before we dive into our session, I'd like to take a moment to ask for your support in helping us grow in our community and recognize the speakers. Firstly, if you're enjoying the content we are providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below this video. Now, for something a bit special, in the video description below, you will find the link to the talk page where you can provide your feedback to this talk, give speaker a badge, and trade for this session if you like or if you don't like. Through the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box in YouTube or via community platform. Our team will be monitoring chats closely and will collect all the questions to discuss them with the speaker after the presentation. And now, ladies and gentlemen, let's welcome our speaker to share his valuable insights with us. Andrei, floor is yours.
Thank you so much, Alexander. Okay. Hey, everyone. Today, I want to share with you some amazing possibilities of LangChain and ChatGPT in the context of working with your documents. These are tricky but interesting technologies, and we will cover configuration and features to improve performance and the quality of responses. We will cover the disadvantages of ChatGPT and advantages of LangChain, as well as huge possibilities of these two technologies working together. Let's explore how these two technologies help each other and work in synergy. A few words about myself. My name is Andrei Semeniuk. I'm a senior software engineer with more than 8 years of experience in creating large systems in the banking, IoT, and security sectors. In the last 4 years, I have been deeply involved in working with big data, Databricks pipelines for data processing and cloud integration. I have set up some projects as MLOps with configuring and storing models in Databricks. Additionally, I actively implement GenAI in production projects. Well, let's begin. I know a lot of people have used ChatGPT. They have accessed it on the web. Essentially, it's a service you can use online. You type a question into it, and it provides an answer. It's a simple chat based on LLM like ChatGPT for providing questions and answers. The next step for using LLM is creating a GenAI application, which uses prompts and responses for step-by-step execution, like a gear in a big mechanism where step-by-step, prompt by prompt, you get a more complex GenAI result. One of the most popular framework for creating GenAI application is LangChain. Let's try to clarify what disadvantages ChatGPT contains. It's a black box. Language models like ChatGPT in isolation only know what they were trained on. They don't have private personal information, such as proprietary documents from company on the internet. Also, they don't contain articles and data what were written after the language models was trained. For ChatGPT, for example, it's internet text up until September 2021. They don't have current knowledge at least up to the year 2024. However, there are some limitations, and we need some extra solution to resolve all these issues, this ChatGPT. Just imagine a solution what allows you to interact with your own data and documents. What if you could have a conversation with your own documents and get questions answered using information from those documents and a language model? What if it could be updated based on your personal information and company documents? This is easily achievable with your support on LangChain and ChatGPT. LangChain helps to create a GenAI application which can work with your personal data or updated data and enrich all this information to the context for question to the LLM, resulting in more accurate responses. Yes, there is an API for ChatGPT. It was released by OpenAI in May 2023. The ChatGPT API allows developers to integrate ChatGPT into their own application, software, or platforms. What LangChain does is it allows you to use the OpenAI API or any other language LLM. LangChain contains 20 plus LLM integration. It doesn't have to be ChatGPT, and it allows you to connect it with other tools and services. LangChain supports a lot of models and connectors like Amazon API Gateway, Anyscale, Bedrock, Databricks, Google Palm, MosaicML, TextGen, and others. However, we will mostly be talking about LangChain and the context of the OpenAI model. But you can use any LLM what is supported by LangChain. Well, this is where the world of innovation around these large language models is changed literally by the hours. Let's begin. Okay, technically, LangChain is a framework what can help to create applications using LLMs, like ChatGPT. One of the most popular use case is chat, with the possibility of huge extra functionality from the LangChain framework, like memory, additional context, self-query request, and so on. For example, LangChain helps to create a GenAI application which saves the prompts and responses from LLM, creating a history context of the question. Also, LangChain can help with summarization tasks, code analysis, copilots, and document analysis. But we will especially cover documents analysis in our session today. Okay. LangChain supports dozens of use cases and connectors, starting with the most popular use cases, the creation of chatbots. Other uses included the creation of copilots, syntaxes checking, semantics checking, summarization, execution of shell scripts, bash scripts, Google search, creation of Python, C++, Java, and other codes, connection with SQL and NoSQL database. In addition, LangChain supports JSON, XML, HTML, and other formats. Moreover, LangChain contains different kinds of cloud connection to Azure, AWS, and Google Cloud Platform, which helps to get scalable performance from the cloud. In addition to this, LangChain contains different connectors for internet search, if needed, like Bing Search or Google Search API wrapper, for getting more context information from the internet. Overall, LangChain supports many more different use cases, which are growing day by day. Okay, LangChain was launched in October 2022 as an open source project by Harrison Chase. In April 2023, the project quickly garnered popularity with improvements from hundreds of contributors on GitHub. LangChain is an open source project what is entirely free for use. You can get the source code from GitHub and use it to create your own application. LangChain Incorporated and the new startup raised our $20 million in additional as $10 million seed investment. The project is growing very quickly and sees improvements and new integration every week. Now LangChain has 5.3 million monthly downloads. Let's discuss how LangChain can work under the hood. For example, when answering a question in a chat with some context information from your document. First of all, we should upload our source information, PDFs, database info, etc., to LangChain's documents. This is called document loading. Next, LangChain splits these documents into chunks based on configuration. After that, these chunks are stored in Vectorstore for efficient storage and use because you don't need all data for answering. The next stage is retrieval. We take the query from the consumer and search in our Vectorstore for relevant splits. We then send the customer's query with extra context from the documents to the LLM. Finally, we get the final answer from ChatGPT based on the query and our documents. Technically, this entire process of adding additional information context in the request is called Retrieval Augment Generation, RAG. In Retrieval Augment Generation, an LLM retrieves contextual documents from external dataset as part of its execution. This is useful if you want to ask a question about specific documents, for example, our PDFs, set of videos, etc. Document loaders contain more than 50 plus implementation. Of course, the most popular formats where LangChain works are PDF, HTML, CSV, etc. Also, it contains proprietary documents loading formats like Word, Excel files. Another important feature is that LangChain can read and work with computer languages code like C++, Java, Python, R, and many others, and generate code for execution. One interesting case is the YouTube loader. For example, you can upload audio from YouTube video via LangChain, YouTube audio loader, and convert the audio to text via LangChain, OpenAI Whisper Parser, and working already with text. It's easy to set up. Loaders in LangChain support a huge variety of file formats for reading. Loaders deal with the specific of accessing and converting data. They can access to websites, including HTML and CSS format, databases, SQL and NoSQL databases, YouTube, Notion, Redis, Wikipedia, etc. We can handle a dozen of data types such as PDF, HTML, JSON, XML, DocX, PPTX, etc. Everything from different sources is uploading to a document in LangChain, which consists of content and associated metadata. Metadata help to provide extra context for searching inside documents, specific documents in LangChain. For example, it can contain information about from which file name and what page this text was taken, or what website URI it was from. It's very useful. There are many different types of documents loader. Here's a rough categorization of the 80 plus what are supported by LangChain. There are many loaders that supported unstructured data. Example, text file from the internet, text from YouTube, Twitter, IMDb, and proprietary, as I already talked, like Word, PowerPoint files, etc. Additionally, LangChain is useful for loading structured data in Excel format, for example, or CSV. Moreover, LangChain loaders contain different database connectors, like Oracle SQL, MySQL, Postgres, Databricks, SQLite, Snowflake, and a bunch of others. In addition to this, LangChain has connection to web chats like Slack, WhatsApp, and others. Okay, what's next? After loading documents in a standard format in LangChain, we can proceed to split the documents. LangChain can split a document into smaller chunks. Chunks help to process searching or request to the LLM step by step and get more granular answers. The quality of chunking will affect the final answers. In brief, it sounds easy, but there are a lot of details under the hood, and it can affect the performance and quality of application. One of the tricky parts of splitting documents is finding the right splitting point to avoid losing meaningful information. One of the tough cases is splitting in the middle of sentences. For example, if the splitter splits your chunks in the middle of a sentence, you get two parts. And then we are trying to answer a question like, what is a brown fox doing? We don't have the right answers in either the first or the second chunks. Similarly, when we're trying to answer a question down the line about the specification of the fox, what is a fox, we actually don't have the right information in either chunk. This is some problem. To resolve the splitting question, we will cover some topics. We will talk about token splitting and how it's organized. Overlapping, which helps resolving the splitting issues by duplication data, and header splitting for some Markdown cases. Overall, LangChain contains more than 10 implementations of text splitters. Let's examine these techniques more deeply. All LangChain splitters are based on certain parameters like chunk size and chunk overlap. Chunk size can be set up in different ways, and it refers to how many characters or tokens which will be in your chunk. Chunk overlap refer to the text what is contained in both the first and second chunk. This is the overlap between two chunks. This allows for same pieces of context to be at the end of one chunk and on the start of the hour. For example, if you have a first chunk size of 500 characters and second chunk size of 500 characters, and the chunk overlap is 100 characters. That means that these 100 characters will be in both, in the first and second chunks. This is very useful. And as we already discussed, LangChain contains more than 10 text splitters implementation for different use cases. For example, character text splitter split text by characters directly. Recursive character splitter is one of the most useful splitters. This text splitter is the recommended one for generic text. It is parameterized by a list of characters. It tries to split on them in order until the chunks are small enough. The default list is /n/n. After that, he tried to split by /n. After that, it tried to split by space. And if can split not all of these choices, it's splitting by simple character by character. Of course, an important part of splitting is when you try splitting code text. For that purpose, a special language splitter has been created, which work with classes, objects, and full syntaxes in different languages like Python, Ruby, and C++, and others. LangChain has a token splitter, which can help to split text based on tokens. ChatGPT works exactly with tokens and splits documents into chunks based on token size. Sometimes it can be words, but other times it can be 1, 2, or several character token. Finally, the token text splitter splits a raw text string by first converting the text into byte pair encoding, BPE tokens, then splits these tokens into chunks and converts the tokens within a single chunk back into text. Tokens are often around 4 characters, but it depends. Another interesting splitter is the Markdown header text splitter. For example, we might want to specifically honor the structure of the document itself. For instance, a Markdown file is organized by headers. Creating chunks with specific header groups is an intuitive idea. It provides the possibility to split Markdown by headers and subheaders and get more meaningful information chunk by chunk. Additionally, intelligent save data in metadata for working with Markdown text. Metadata also saving, and we can use this in our next responses. How we can move our small, meaningful chunks into an index. This allows for easy retrieval of these small chunks when they are needed by a request. But we want to do it in a lightweight and efficient way. For this purpose, we can use embedding and Vectorstore. Let's see how it works. Okay, the idea of vectorization, to understand vectorization, understanding efficient storage of text, we should discuss the idea of vectorization. Also, we will talk about embedding, which helps with working with text and number formats. Vectorstore, which efficient save these numbers, and similarity search for sharing some useful cases of vectorization. Let's check. Vectorization is a more general process of converting non-numeric data into numeric form so that it can be used by a machine learning algorithm, for example. This can include one-hot encoding, back of words, and others. Embedding, on the other hand, is a specific type of vectorization, mainly used in natural languages processing. It is a learned representation for text where words with the same meaning have the similar representation, which is not necessarily the case with general vectorization techniques, It is a way of identifying semantic property of the words. What is the vectorization? Simple words. This is the process where LangChain takes a pieces of text and creates a numerical representation of that text. Text with similar content will have similar vectors in the numeric space, and it will be useful for using it in request. But let's talk more deeply about embedding. For example, the phrases "my cat" and "my dog" will have similar numeric representation in embedding because they contain the similar word "my." On the other hand, the phrases "my cat" and "car is" will not be similar in their embedding representation because they contain different words in content, and where numeric representation will be far from each other. It's a simple idea, but it can help speed up the searching process inside text a lot. Okay, next is Vectorstores. Vectorstore is a database where all embedding and chunks are stored in one place. From this Vectorstore, you can easily look up similar vectors later on. This becomes useful when we're trying to find documents, what were relevant to a question at hand. When a question from a customer comes in, LangChain can quickly find relevant chunks based on the embedding representation, send these chunks as context in the customer request to LLM and get the answers. Similarity search, this is another feature. Similarity search is a process where we take a question from a customer, find chunks in the vector stores with similar embedding numeric representation, and return similar chunk for context. This can improve performance and the quality of results. Also, we can specify how many documents we want to take from Vectorstore. For example, if we set up the configuration, for example, for 2 documents, LangChain will return the most similar documents based on the query, for example, 2. Okay, the next step is to retrieve related chunks based on the customer request. We begin working with the customer request only at this step, then our Vectorstores already prepared. Why? But in this case, we achieved higher performance for querying when we have prepared text. This is important at query time. When you got a query, what comes in, you want to retrieve the most relevant splits from the Vectorstore. Basically, for retrieval, LangChain have several methods for semantic similarity search. I want to cover some of these methods, like addressing diversity via maximum marginal relevance, addressing specificity, self-query retrieval, which works with metadata and can perform several actions from one request, and compression, which provides a more granular context for the request. Overall, LangChain contains more than 5 implementation of retrievals. Let's talk about maximum marginal relevance, or MMR. Okay, the idea is behind MMR is what if you always take the documents what is the most similar of the query in the embedding space, you might actually miss out of diverse information. In diverse, sometimes it's important, very important. For example, if we search for the request doc, we might get the most similar documents, doc talk, and that's it. But MMR extends this document with 2 less suitable documents, Royal Corgis and Collie Slav. All 3 documents returned in the responses. In this case, the second documents about Corgis might be more relevant to the answer, and probably it will be right choice. And this is diversity of documents. Okay, let's move into MMR algorithm. Under the hood, MMR algorithm works with some parameters, diversity. Firstly, LangChain takes the most relevant responses from the Vectorstore based on the query. In the second step, using this diversity parameter, the MMR algorithm selects the most diverse responses from the top responses for answering. In this case, using these diversity parameters, we can control how many responses we get. Using MMR, we can get a greater variety of documents for a better results in our any cases what we have. Okay, another very interesting type of retrieval we can do is what is called self-query. This means what in cases when you ask a query like, what is the most popular doc movie in 1985? The retrieval makes the first request with docs movie. And the second query is for filtering by metadata. Here it will be movies what were created in 1985. In this case, the language models from the query does two things. It creates the query and the filter statement. It's done automatically under the hood, and you only need to set up this retrieval. After that, Vectorbase can efficiently filter by metadata, and that's it. You get some things instead one automatically. Okay, and another useful method for retrieval is compression. This helps to increase the documents for the LLM in context by cutting from the document only the information relevant to the query, not all information. It may require more calls to the LLM, of course, but it helps to make the final answer based only on related information. For example, when you're asking a question, you might get back the whole document, what was stored, even only if the first one or two sentences are the relevant part. With the compression, you can then run all these documents through a language model and extract the most relevant segments, only relevant segments, nothing more, and then pass only the most relevant segments into a final language model call. This comes at cost, of course, of making more calls to the language model, but it's also really good for focusing the final answering on only the most important things. A great feature that LangChain provides is the possibility to combine different techniques like compression and MMR to get the best results in retrievals. It's also important to check the configuration for time query and the quality of results. When using one retrieval method or another, for example, LangChain provides an easy way to change retrievals with just a few changes in the code lines. That's it. And you can just play with this feature. It's very useful. Also, you can use more traditional NLP techniques for retrievals like support vector machine, SVM, or term frequency inverse document frequency, TF-IDF retrievals. This provides you with the possibility to compare the quality of traditional or modern solution for your use cases. Regardless, LangChain can help you to migrate your pipeline as is. It's already set up. But you can also check out the new feature retrievals, which LangChain provides a lot of. The last step, as we have already partially discussed it, is output. On this step, LangChain takes those documents, takes the original question, passes them both to a language models and asks it to answer the question, finally. And finally, we get the answers. Okay, the general flow for this goes as follows. The question comes in, we look up the relevant documents, we then pass those splits along with a system prompt and the human question to a language models and get the answer. By default, we just passed all the chunks into the same context window, into the same call of language model. And this small context window can be really restrictive for some cases. But however, there are a few different methods we can use for this. Let's check it. Okay. And by default, LangChain just puts all relevant documents in the final prompt. And of course, sometimes this context window may not be enough for a clear response. It's too small. We have at least 3 methods for resolving the problem, a small window context. This is a MapReduce, which makes some summarization of each chunk. Refine, which provides a step-by-step process to make the request better. And MapRerank, which helps to find a better request. Okay, one technique for using a small context window efficiently is MapReduce. In this technique, each individual document is first sent to the LLM by itself to get it an initial answer. After this, those answers are composed into final answer with a final call to a language model. It looks like for every document, the LLM makes an answer summary, and the final prompt makes a finally summary from all the answers. Of course, it requires a lot of calls to the LLM, but the quality of answers can be better because more documents are involved in the final answer. It's very useful. Another chain type is refine. In this technique that invokes the refined documents chain, sequential calls are made to LLM step by step. Firstly, the LLM makes a call to the LLM with the first document and gets some response. After that, LangChain makes a second call to the LLM, adding the response from previous call and due data, and then ask to improve the first response if needed. If the second response is better than the first, the LLM improves the second response and uses the second response as context for the third request, and etc., step by step. This process repeats until all documents have been checked by human request with the previous context, and then the final answer is obtained. Of course, it's also taken a lot of LLM requests, but quality can be better and better on each step. And the final technique of chain type is map rerank. It's pretty similar to MapReduce, but here with each responses in the documents, a score of the quality, confidence of the answer is also added. These scores are set up automatically. We don't need to set up something by the LLM based on the accuracy of the answer and provide opportunity to choose the best option. The final LLM call is made with the high score responses up and provide more relevant requests. It's good, very good feature of LangChain, which can help very quickly to growing up the quality. Also, we should talk in. I want to say a couple of words about memory. The most popular use case for document retrievals is chat, as you know, which provides the possibility of talking with your data. For real conversation between human and LLM, we need some memory, which has a history of questions and answers. In LangChain, we can use conversation retrieval chain, which provides a memory function. Using this retrieval, you can use chat history. This chat history contains all questions and answers from the LLM which were present at the moment of conversation. LangChain adds this history to the context to get a better quality of answer. For example, you can ask, "What my name is Andrei," and ask to the second question, "What is my name?" And LLM will answer it, "Yeah, your name is Andrei, sure." Also, a good feature is what all retrieval techniques, as we talking about before, like self-query or MMR, can also be used in parallel for chat history. It can be just adding here. Another important topic what I want to cover is evaluation. It's not only related to document cases, but also to any use of ChatGPT and LangChain. When you're building a complex LLM application, well, the important thing is to evaluate how your LLM application is working. Is it meeting some accuracy criteria, or you might decide to change, for example, the LLM or vector database in the future? For all these cases, correct evaluation is needed. And here we have two global points of view for evaluation. The first one is making examples and evaluations from the human side. The second approach is using the LLM to generate examples and evaluate the quality of answers from the LLM. The first thing we have when we think about evaluation is providing some examples from humans and providing examples of answers which we can use for evaluating the LLM's responses. after that, we can create the answer to this question and evaluate the quality of the LLM's answers. We can do this manually, step by step, with granular choosing example. It's good. This can work well, but it takes some time and may not scale enough to cover different cases, because cases can be a lot. The good news is what we can use the LLM itself for generating question and answering for checking. Using LangChain tools like QA Generate Chain, it's easy to create questions and answers based on each document in seconds. For evaluation, using the QA eval chain, LangChain can evaluate the quality of answer from the LLM. In this case, we provide a bunch of examples and predictions to this QA eval chain, and on output with evaluation returns and list of grades based on accuracy for each responses. Overall, we can generate examples and answers using the LLM and evaluate the quality of responses based on logic via LLM. And this option speeds up the process of evaluation and increases the variety of questions and answers. Okay, let's talk about huge possibilities. LangChain ChatGPT has a huge range of uses based on its connection with different formats and additional queries for data like SQL, we're already talking. And also the most popular cases for using LangChain are chat creation and different kinds of copilots. Now it's everywhere. All companies have some copilots. Talk to your data or talk to your docs is a great possibility to use confidential information to working with the LLM without any restriction, only with restriction from your side. And also an important case for LangChain ChatGPT is the security area. For example, fraud detection and behavior deviation. It's also very important stuff. And finally, I want to share some useful resources for more in-depth research into LangChain possibilities. I suggest a very good courses on Udemy about LangChain. Also, a good resources is an official LangChain website which contains UI visualization in every step-by-step of query and responses. You can check how it's going on. For example, you're making your request in LangChain and got it and see in UI how it's going through. And for researching ChatGPT, I suggest the OpenAI platform itself. Okay, well, I think that's it from my side on today. And if you have some question, please go ahead. I will be glad to answer on stuff like this.
Yeah, thank you very much, Andrei. We have several questions. Let's discuss them. So, yeah, here's a question. Is it possible to fit project documentation or company internal KB and use it as an assistant? As I understand, yeah.
Yes, sure. You can prepare your documents if you want. For example, you're uploading all documents, for example, from KB and making one big stuff like CSV and putting it like pre-indexes on Vectorstore. Or you can, for example, making some crawler. I mean, because if you need some one of the point of information, you can set up it. For example, if you need some extra information, going to the internet, for example, using Google search or some internet connection, going to KB page, getting only needed information from HTML and enrich your request. Or you can, for example, download all information what you have and working within in Vectorstore. Yeah, it's totally possible.
And yeah, so as I understand, it helps to create some chat where, for example, workers can, or like anybody can just talk with this chatbot. Yeah, and does it actually asks for details? For example, like if my question is not detailed enough, or like can it just ask for more details? What exactly I mean?
Yeah, sure. This is why it needs this context using documents. You can talk with which you already inside and context. You uploading all these documents and LangChain or ChatGPT knows context inside these documents, and you can ask him, for example, what is my possibility to contribute, and he know what, for example, on EPAM you can work in several cases for contributing and answering for based on this possibility, and tell, okay, you can come into to Data Zen community and making some very good stuff. And this is why, from what source it's taken. It's taken from documents, for example, from KB or from another documents. Yeah, it's a very good feature that you're talking like a people, like a human who already knows the same context as you based on document.
I mean that, so for example, okay, you ask this question, but for example, instead of giving like a list of 10 opportunities, it can can it ask question? Can it give me a question, like to ask for more details? Something like that. What exactly do you mean?
Clarification.
Do you mean that or this? Yep, exactly.
Yeah,
Clarification.
some clarification. It can be because it's contain history. It's contain chat history, and if it's not enough information on this chain, he talking that I have no so deeply information. Could you kindly clarify what exactly do you mean? For example, I have one choice and I have second choice, but what exactly do you mean? Could you kindly clarify?
Yes.
And because it's storing memory, as I've already shared, it can be based on all history, answering deeply and with more quality.
Okay, and so does LLM support feedback loop? Can it just, for example, teach based on my based on like my rates for the answer? So can I mark something like, no, this answer is wrong?
Again, in the context of history, as you know, as I'm beginning from the initially LLM is a black box. It's fixed. It's not modifiable, and you can just only answer and get an answer. And we need to work as is this. But using history, for example, you making one answers, and then LLM and via LangChain will be answering to a question. It will be see previous historization and got it. For example, what style of answering you want to answer and what is the correct answer, what is before. And based on historization, it's easy. And of course, based on correct context. For example, if you're uploading your documents, it can be more higher priority based on, for example, some knowledge that LLM already know, because your documents, it's more private. I mean, it's more probably more correct answers initially. You can set up it, and it will be more high ranking for answering.
Yeah. Also, there is a question about this Vectorstore, where, as I understand, like the whole knowledge base of LangChain is stored. So where is it actually stored? Can it be stored in like SQL database, or what is it?
No, it's stored on vectors. I mean, you can set up some vector database, like, for example, Milvus, most of the popular, and that's it. It's some specific. It's not SQL database. It's some specific database you can set up. But you can using by default. It's some Vectorstore as is. From LangChain. But
so it's a separate database. It means that you can
you can set up separate, some specific database for that purpose, but LangChain has, as is from under the hood, some small realization of vector database.
Yeah, but for example, to support like millions of requests, probably it's better to have separate.
Like for Milvus, it's separated. For example, a vector database which stored all information, all needed in embedded version. It's numeric representation with, of course, with text, which is also contained. And for example, you're making your request. It's quickly searching by indexing what exactly text related to that, and provided only that documents what needed. Of course, with all techniques what I'm talking about, with diversity, MMR, for example, it can compress it can make in some diverse responses and making some more variety of more accurate answer to your question.
And comparing to ChatGPT, does this LangChain support message translation, or question translation? I mean, may ask, for example, in Polish or like in another language?
Yeah, it's totally. Again, it's LangChain. It's only provider. I mean, about it's finally it's framework, but it's working with LLM and, for example, ChatGPT and ChatGPT train it on English language, but it contains a lot of translation, and you can ask it on Polish, of course, but LLM like ChatGPT will be thinking on English, and after that, if needed, again translate it to the Polish. For that case, better case to work in everywhere on English, but documents what you come in, it can be on Polish language, on Chinese. It's you don't need to learn it, but store it. I mean, about then LangChain will be making operation. It will be working with English language.
Yeah. So also there is an idea. Maybe it's possible to export and publish your vector store. So if there is some maybe repositories, public repositories of like custom vector stores. So for example, like to create some knowledge base of, for example, of this like internal company knowledge base.
Sure. As I know, Milvus, for example, it's open source vector stores and you can use it. But main for you is set up these vector stores in your company. And again, as all documents, for example, you're uploading, it's closing. It's no have open public API. And the same with vector stores. It's internally and nobody see, only LLM if making response. And you can, for example, now for answering the question, set up LangChain that answering, for example, and don't touch some themes. And for example, especially, for example, or taking this part mostly, you can configure what exactly you, for example, want to make more polite speaking, and it will be enough for LangChain. It's like it. For example, if you're talking about chatbot, for example, it's easy to set up like system message, please talking more politely and talking more about some themes, and it will be configurable to this way. Sure.
Okay, interesting. Yeah, and I think that concludes our session. Thank you all so much for joining us today. We hope you found the session insightful and inspiring. In this video description below, you will find the link to the talk page where you can provide your feedback on this talk, give speaker a badge, and rate the session if you like, or maybe if you don't like it. And additionally, you can revisit it. You can download the presentation on the talk page. So check video description for the link. Thank you very much, Andrei, for this session. It couldn't happen without you. Once
Thank
again,
you so much.
Thank you all for participation today.
Thank you. Bye, everyone.
Bye.